So the statement for Rolle's theorem is let f is a mapping from the closed interval AB to the set of real numbers R. Okay, and be continuous means this function is continuous in the interval continuous be continuous on this closed interval AB. And also differentiable in the open interval, differentiable on the interval AB, open interval, and B the endpoints we will not take. Endpoints it is not differentiable because at end point of a curve we cannot draw the tangent. That's why. Such that fa is equal to fb means the function is continuous, differentiable, and fa is equal to fb. The value of the function at a and b should be same. A and b are some where real numbers, where a and b are some real numbers. Any real numbers, a and b are some real numbers. Then now then there exists a point C between A and B. Then there exists a point C. There exists at least one point, at least one C point in closed interval. Means it should not be at the end point A and B such that f dash C is equal to 0. Okay. So let me explain it. Suppose this is our x-axis, this is our y-axis, and A and B are 2 points. Here, this is A point and this is B point. Okay. So they said that this curve is a, suppose the curve is starting from here at this point, so it will end at this point, as they have said FA is equal to FB. So from this point the curve starts, okay, and it is continuous. So obviously if its value will increase, then it has to come back to this point because this is same. So this is what, this is FA and also the same length here. So this is also FB. FA is equal to FB on y-axis. This is O, this is x-axis, this is y-axis. So when the curve will start going up, or it can go down also. So there will be a point where it will reach to its maximum height. Means suppose that point is C, because C is a point where the differentiation is 0, means derivative. So derivative is a tangent at that point. So if you draw at this peak point, if you draw a tangent at this point, so it will be parallel to x-axis. Correct? This will be parallel to x-axis, this tangent. That means f dash t is equal to 0. If the tangent is parallel to x-axis, that means the derivative at that point is 0, means slope is 0. Derivative is what? The derivative is representing the slope of a tangent slope of a tangent at that point. At that point. Okay. Means derivative represents the derivative represents the slope of a tangent at that point. So you can see they have said it is starting from A and B both are included. It is continuous. Means that this graph should not break at any point. If it is continuous, then any point we can draw the tangent. Here we can draw the tangent at any point. So means it is differentiable, but not at A and B, because A at A, this point at this point, at this point A and this point, it is not said to be differentiable because this is the end point. At end point, you cannot draw the tangent because this is the end point. If it, suppose this is ending at this point, you cannot draw the tangent at this point because it can go up. If it will go up, tangent will be like this. If it will go down, tangent will. So the end point we cannot draw the tangent. Okay, there are finite tangent. They cannot said to be a tangent because tangent should touch the point. Okay, here this point is ending. So at the end point, so that's why it is called differentiable in the open interval. Means A and B are not included. Open and close interval you have seen. Now open interval means A and B are not included. Close interval means A and B both are included. Okay. So this is C point where this. Okay. So we have seen if it is increasing. Similarly, if it will decrease also, then also the same thing will happen. If suppose this is A point, this is B point, and wherever it is the height, suppose this, from this height, it will start going down. Then obviously it has to come back at this point because this is the condition. It has to follow that FA is equal to FB. This height should be equal to this height. This is called FA and this is called FB. So FA should be equal to FB. On y-axis we are taking FA. Value of A at value of F at A taken on y-axis. This is FA or FB here also. The same thing. This distance is what? FA or FB. And this distance is A and this distance is B. So similarly here also if you draw a tangent, this point will be C and the tangent parallel to x-axis means its slope is 0. So that's why you can say that f dash c is equal to 0. So this is the Rolle's theorem. Okay. So how the question is coming to verify the Rolle's theorem. So method, how will you verify? The question will be given. You have to just verify the Rolle's theorem. So I will tell you the method to verify. How will you verify? Method to verify Rolle's theorem. So we have seen the conditions. Yes. So first of all, write the given function and show that fx is continuous. Standard result of continuity. We use the standard results of continuity means standard result of continuity we have seen like polynomial, all polynomials are continuous at every point. So we first write the given function, write whatever function is given, write the given function, first step, write the given function fx and show that fx is continuous. First continuity, fx is continuous in the interval, on the interval, in the interval AB, close interval, For this, we are not going to do left hand limit, right hand limit. Generally, we will find the standard results. So for this, we generally use the standard result. For this, use the standard result. Directly, we can use the standard results of continuity. So first of all, we will show that yes, it is a continuous function. Then second condition, it should be differentiable. Third condition, f is equal to fb. So there are three conditions. You have seen three conditions: continuous, second differentiable, third condition f is equal to fb. So these three conditions we have to show. Then we can take some point. So first condition, verify. Then show that second condition, differentiability. So here also show that fx is equal, fx is differentiable, is differentiable on the interval a b, open interval a b. Also use standard result. Use here also we can use standard results. Generally here we are not going to prove that it is continuous differentiability, left hand limit, right hand limit, left hand derivative. No, no need. So you will find the question like this. You can directly write the answer for continuity and differentiability. Now find the value of fx, and now third condition is fa is equal to fb. We have to prove that fa is equal to fb, and interval will be given in the question. So now we have to show that fa is equal to fb. For that means show that means find fa and fb and show that fa is equal to fb. Both should come equal, then only Rolle's theorem exists, satisfies. Otherwise, Rolle's theorem will not satisfy. So then all the conditions, thus here, then you will write thus fx fx satisfy all the conditions, all the conditions of satisfies the all conditions of Rolle's theorem. Okay. Then fourth point. Now find first derivative of fx and differentiate with respect to x, because f dash x is equal to 0. So you will find f dash x. So now you will find the first derivative fx, means you will have to find fx. So find fx, find first derivative means f dash x, not fx, f dash x. Find first derivative of fx. Okay, that is differentiate fx with respect to x. That means you have to differentiate the given function with respect to x. So differentiate fx with respect to x. And then fifth point, the last point, you have to put the value of x is equal to 0, x is equal to 0 in f dash x and equate to 0, and write f dash c is equal to 0, okay, and simplify to get the value of c. So this value of c, whatever value of c will come, this should belong to the interval, find the c which is between the value between a and b, then it will be verified. Okay, so question is now verify Rolle's theorem, verify verify Rolle's theorem for the function y is equal to x square plus 2, a is equal to minus 2, and b is equal to 2. So interval is also given, function is also given. Y means we have given fx. So now first we have to check the continuity. And since we have this function, since we have fx is equal to x square plus 2, which is a polynomial. So a polynomial function is always continuous on, you can write plus 2, and we know that you have to just write here that the standard result you have to write, and then you can say it is continuous. So we know that a polynomial function, this is a polynomial. So a polynomial function is always continuous, is always continuous on real number, any real number r. So therefore, we can say that fx is equal to x square plus 2 is continuous in the interval, on the interval is continuous on close interval minus 2 and 2. Here interval is already given. Okay. And similarly, we know that a polynomial function is differentiable. Same, we know that a polynomial function is differentiable. It's differentiable on real numbers. So fx is equal to x square plus 2 is differentiable. So mostly in these 2 points, you have to write always the standard result. Minus 2 and 2, differentiable in the closed interval. Third point. What was the third point? Third point, we have to find fa and fb and show that fa is equal to fb. To find fa means we will find f minus 2 first. Fa means f, value of a is minus 2, f minus 2, then its value is minus 2 square plus 2, that is equal to 4 plus 2 is equal to 6. Then find fb. fb means f2, that will also come 6. Okay, so thus all, that means you can write f minus 2, f minus 2 is equal to f2, thus all conditions, thus all conditions of Rolle's theorem are satisfied. All the three conditions are satisfied. Now we have to find the derivative. Okay. We have fx is equal to, that is our fourth point here. Derivative. We have to find the derivative. So fx is equal to here x square plus 2. Find the derivative f dash x. Fx is equal to, given us x square plus 2. Okay. So fx is equal to x square plus 2. Find the derivative. So differentiate with respect to x. So differentiate with respect to x. So we get f dash x is equal to 2x. Okay. And now put x is equal to 0, equate to 0. Put x is equal to c and equate to 0. And equate f dash x to 0. So that means f dash c is equal to 0. F dash c will be equal to 2c. 2c is equal to 0. So c is equal to 0, and which is belonging to minus 2 and 2. It is necessary. If it is not belonging, then we cannot verify. So it is belonging to C, hence we can say that Rolle's theorem has been proved, verified. So hence Rolle's theorem is verified. Okay. So these are the conditions of Rolle's theorem. There is a slight change in mean value theorem. In mean value theorem, the condition will be different. Small changes there in mean value theorem. F is a, I'll write in short. You can see the statement from the textbook also. If AB is a function from the closed interval, B continuous, same condition. B continuous, first condition. B continuous on the closed interval and differentiable, and first two conditions are same, so we will prove this by the same way, and differentiable on the open interval AB. Then there exists, now f is equal to fb is not there, then there exists, this is the sign for there exists. There exists at least one c in the interval, meaning between a and b there exists a point c such that we have to show that, such that, so we have to check two things, and then we have to apply this. F dash c should be equal to fb minus fa upon b minus a. Okay, this is also called Lagrange mean value theorem. LM. This is also called Lagrange mean value theorem. Okay, so in order to prove the same thing will happen, for example, suppose we have given the question as fx is equal to x cube minus 5x square minus 3x. In the interval is given as 1 and 3, 1, 3. Okay, we have to verify there exists, find all the, first verify. Okay, so verify, and then one more thing, they have asked all the values of c. Verify, and this we have to verify LMBT means Lagrange mean value theorem, and find all c values. So first condition, it is continuous because it is a polynomial. You can see from the previous question, it is continuous, it is differentiable because it is a polynomial. And according to the mean value theorem, now we have to find the condition is f dash c is equal to, so fb minus fa. So fb is 3, f3 you will find means 3 cube minus 5 into 3 square minus 3 into 3, and you can solve it, you will get minus 27. And find f1. F1 is 1 cube minus 5 into 1 square minus 3 into 1 is equal to, answer will be minus 7. So f dash c should be equal to fb minus fa. So for f dash we need to have f dash c. So f dash x, find f dash x will be equal to 3x square minus 5 to the 10x is minus 3. Then what will be f dash c? So f dash c will be equal to 3 c square minus 10 c minus 3. Okay. So according to the according to LMVT, f dash c will be equal to what? Fb minus fa upon b minus a. Okay. So f dash c, what is f dash c here? F dash c is 3c square. Means you will get one equation that you have to solve. So fb is minus 27 minus plus 7 divided by f b minus a means 3 minus 1, 2. So like this you will get in a quadratic equation. When you solve it, you get a quadratic equation 3c square minus 10c plus 7 is equal to 0 on solving it. 2 minus 20 divided by 5, so this 5 will come here, will become 3c square, 3 minus 1, 2, minus 27 minus 7 minus 20 divided by 2, so minus 10 will come here, 10 minus 3, 7, correct. Then here if it is difficult to get the means splitting the middle term, you can use the formula minus b plus minus under root b square minus 4ac upon 2a. Okay, so here minus 10 square b square minus 4 into a into c divided by 2 into a, 2 into 3. So all will become 10 plus minus this root will become 100 minus 84. 84 minus 100, 16, that is 4 upon 3 to the 6. So taking positive sign, so value of c will be 1 and 7 by 3. So but 1 will not belongs to uh, but 1 will not belong to the interval 1. It should belong to the open interval 1, 3. So it is not belonging open in an open interval. So we will not take this one, and but c is equal to 7 upon 3 will belong to this. It will belong to this interval 1 and 3 open interval. Hence LMVT is verified. Hence LMVT is very, and we got the values of also C. This already we get, always we get this value whether asked or not. Okay. So like this, now you can see your textbook. You can go through all the questions. This is all about the verification only. Verify Rolle's theorem, verify mean value theorem. So that is the end of this chapter.